Hello everybody, it's Miss Fincham, and we'll be continuing Unit 1 by covering Topic 4.1, which is Plate Tectonics. Thanks to Justin Smead for the slides and note outlines that we use in class. We will start off our coverage of Unit 1 by talking about the fact that, believe it or not, the entire world we see and experience, the land, the oceans, it is all just a really thin layer of rock floating on an ocean of magma. This thin little rock layer that we live on is called the lithosphere. It is broken up into chunks called tectonic plates. We have a mountain in the background here because tectonic plates colliding is actually what creates mountains. In this video, we will be covering how mountains are formed, along with all other geological formations that can be caused by tectonic activity. Our objective for the day is to be able to describe the geological changes and events that occur at plate boundaries. In order to do that, we need to know that there are three plate boundary types. Those are convergent, divergent, and transform fault boundaries. We will also learn what type of events and landforms each of these can produce, and then finally we'll learn that earthquakes occur when the stress overcomes a locked or a stuck fault, which releases tons of energy. Our suggested science skill for today is explaining how visual representations of environmental concepts relate to environmental issues. We will be looking at some diagrams of different plate boundary types as well as a map of global plate boundaries to practice this. Before we talk about plate tectonic activity, we need to have some basic definitions of Earth's different layers here. At the very center of Earth, we have the core. This is a dense mass of solid nickel and iron, but it has radioactive elements as well that are going to release massive amounts of heat. All of this heat that's released from Earth's inner core turns the next layer around the mantle into a sea of magma. It is the superhot magma that is going to drive the movement of the lithospheric plates above it, which is the basis of tectonic plate activity. If we look outside of the mantle, we'll see this very thin layer called the asthenosphere. This is a semi-solid rock layer that exists on top of the mantle. The layer that we'll be focused on today is the lithosphere. This is a very thin, brittle rock layer that's Earth's outermost layer. That is the layer that's broken into the tectonic plates that we'll be talking about. Then on the very top of the lithosphere, we have the crust, and this is where soil, plants, and organisms live. This is where all of life on Earth exists. The crust is divided into two different types of tectonic plates. Continental tectonic plates are less dense, thicker, and composed mainly of granite rock. Oceanic plates are denser, thinner, and are mainly composed of basalt. So let's talk about the three different types of plate boundaries. The first type of plate boundary is a divergent plate boundary. This is where plates are moving away from each other, and they're doing this because of heated magma from the mantle that's rising up towards the surface and pushing the plates apart. This is going to form mid-oceanic ridges, which you can think of as underground mountain ranges. It is also going to form volcanoes, seafloor spreading, and on land it can form something called a rift valley. Next, we have convergent plate boundaries. To converge means to come together. This means these are plate boundaries that are colliding or moving towards one another, and when they come together, one of them gets subducted or forced underneath another plate. We can see in the diagram here, when they collide, one plate is forced down beneath the other, and that's the subduction. This leads to the formation of mountains, island arcs, earthquakes, and volcanoes. The last type of plate boundary is a transform fault boundary. If we look at the diagram here, we will see that this is when two plates are moving alongside each other in opposite directions. The problem is that when they try to slide past each other, they sometimes become stuck or locked. They keep trying to move past each other, which builds up a lot of stress, and when that stress is overcome, they release suddenly, which gives off a ton of energy called an earthquake. Convection cycles are cycles of heating and cooling magma that rise up to the surface of the lithosphere, cool and expand, and spread out along the surface of the lithosphere, then sink back down in the mantle to repeat the process again. If we look at this diagram here, the center point where the magma is rising is called a hotspot. This is where the magma is super hot, and as it rises, it actually melts the edges of these plate boundaries and forces them apart, which creates this divergent boundary. If we look at the diagram, we'll see this ridge that extends at the plate boundary. This is called a mid-oceanic ridge. When the magma hits the lithosphere, it actually forces it upward a little bit, forming a ridge. Now, if the magma rises with enough force, it can actually force its way through the lithosphere, causing a volcano. When the volcano cools, what is left is an island. We can see this on the map at the end of this video, where we will have some islands that appear in the middle of the ocean, and oftentimes these can be formed at divergent plate boundaries. It is also important to note that this magma, when it meets the lithosphere here, cools and forms a new lithosphere to replace the plates that it's pushing apart. It also continues to cool and spread below the surface of the lithosphere, which pulls the oceanic plates apart, causing them to run into continental and other oceanic plates, forming subduction zones. Since the oceanic plate is more dense, it sinks or subducts beneath the continental plate, melts, and turns back into magma to complete the convection cycle all over again. The pressure of this oceanic plate pushing its way underneath the continental plate can also force magma underneath the continental plate up to the surface. This can create a volcano on land and can also lead to narrow coastal mountain ranges, such as the Andes in South America. The convergent plate boundaries cause subduction, or the sliding of one plate underneath another. It is important to know that this can happen between any two types of plates. We'll talk about how landforms and events occur at each example. When two oceanic plates collide on the left here, one will subduct beneath the other, and this forces magma up to the lithosphere, which forms volcanoes. This magma will continually rise up to the surface in the same spot, but the plate above it is shifting, so each time it erupts, it makes a new island, which is what gives us island arcs, such as Japan or Indonesia. Can also form offshore trenches when the margin of one oceanic plate is pulled down beneath the other. When an oceanic plate collides with the continental plate, the oceanic plate is subducted beneath the continental plate because it's more dense. The oceanic plate melts back into magma in the mantle, but also forces some magma up towards the surface of the lithosphere, leading to volcanoes, but this time on land. They can also create narrow coastal mountain ranges, like we've already seen in the Andes of South America. We can also see trenches and tsunamis formed at convergent plate boundaries. Finally, we have continental to continental plate collisions, which subduct one plate beneath the other, but also push some of the crust upward, which forms large mid-continental mountain ranges like the Himalayas. At a transform plate boundary, we have two plates sliding past each other in opposite directions, which creates a fault or a fracture in the surface of the lithosphere. Earthquakes occur primarily at transform fault boundaries because the jagged edges of the two plates get caught on each other and they become stuck or locked. The two plates are trying to slide past one another, their edges are rough so they catch, and they essentially become locked. The edges of these plates remain locked together even though the plates themselves are moving in opposite directions. What happens is this builds up tremendous pressure over time, and when the stress pulling the plates in opposite directions overcomes the locked fault, the plates will suddenly slip free all at once. That will release a tremendous amount of energy and send shock waves throughout the ground. We can see these waves spreading throughout the ground in this lower diagram, causing the earth nearby to shake violently, and that's what an earthquake is. Finally, the last thing we'll be talking about today is how this map of tectonic plate boundaries can help us predict the locations of everything from earthquakes and volcanoes to new islands forming. The first we'll look at is called the Ring of Fire. The Ring of Fire is this pattern of volcanoes here that we see all around the Pacific plate. The reason we see volcanoes here is because these are all areas where we have convergent zones. What that means is this more dense Pacific plate is converging with and subducting beneath the continental plate. What that does is forces magma up to the surface on the continental plate, which leads to these volcanoes in this predictable pattern. Again, we call it the Ring of Fire because it's a ring of volcanoes all around the Pacific plate, where we have a convergent plate boundary. That is a very important thing to remember. Convergent plate boundaries are primarily the ones that lead to this volcanic activity. We can see in orange that we have transform faults. Transform faults, remember, are most likely locations of earthquakes to occur. If we look at the coast of California, somewhere that we know receives a lot of earthquakes, we'll see it lies right along a transform fault boundary. We can also look at Haiti. Haiti lies right along the transform fault boundary between the North American plate and the Caribbean plate. This is why we know that there's also going to be a lot of earthquake activity in Haiti, who in 2010 suffered one of the worst earthquakes in recent history. Finally, if we look at the white, we'll see the divergent plate boundaries. This is where we're going to see mid-oceanic ridges, sea floor spreading, and potentially even volcanoes. When the magma is rising up between those plates and cooling to form islands, in this case we have Iceland here, but we can even see hotspots that are not necessarily associated with the plate boundary, where we have volcanic activity creating chains of islands just due to the same hotspot constantly shooting magma up to into the lithosphere. In this case, that would be Hawaii, right here. Our practice FRQ for today is explaining how environmental concepts and processes relate to broader environmental issues by using visual diagrams. Think about the visual diagrams from today and try to use them to explain how subduction leads to volcanic activity. When you finish, take a picture of your notes and submit them to Canvas to 4.1 Plate Tectonics. Remember to submit all pages when you're turning in your notes.